Good morning, class. Today we're going to talk about identifying types of reactions. Just like yesterday, we're going to make a chart to help us have the rules on one nice handy page. And then we're going to cover a couple examples. This is going to be very helpful because later we're going to have to predict the products of such reactions just by knowing the reactants alone. So knowing how to identify what type of reaction is happening is going to be super key. Let's get started. Let's recap and put the rules that we have into a chart. So for a synthesis reaction type, there are some things. The rule is it's two reactants become one product. And those two reactants usually will be elements. So that's what you can do to help you find out whether it's a synthesis or not. If you see two things become one, you know it's a synthesis. Or if you only have the reactants, if they're only just elements, then you know the most likely scenario is that they will synthesize and come together to become one product. What about decomposition? It's when one reactant becomes multiple products. So if you are trying to identify, if you only see one reactant, there's only one thing that single reactant can do, and that's split up and decompose. How can you identify something that's undergoing single replacement? That's when one element reacts with one compound. So if you ever see a single element reacting with a compound, you know it's going to be a single replacement. A double replacement is when you see two compounds reacting together. If you see two compounds reacting together, it's going to be most likely a double replacement. There is a little exception to that because a neutralization involves two compounds reacting. But a neutralization is special because it's going to be an acid, which we know starts with H, and a base reacting, which we know ends with OH. So if you ever see an H and an OH, you know it's an acid and a base, you know it's a neutralization. And last up is our combustion. This is any organic so organics are made of C's, H's, and sometimes O's. So they're carbons, hydrogens, and oxygens. We often call those hydrocarbons, and they react with O2. So if you see any organic react with O2, you know it's got to be a combustion. Now the nice thing is that the combustion always makes the exact same products. So if you see the products of CO2 and H2O, you know that it is a combustion. So now we have a chart that covers all 6 types of reactions, and we have our rules for identifying. Let's try to apply these rules and on some example problems. Let's take a look at the first one. I see I have C6H12 plus O2. Wait a minute. That is just like the organics that I described before, and that's O2. And if we take a look, the products are CO2 and H2O. This matches our last rule entirely. This has got to be a combustion, or I'll just write C. There we go, that's the first problem. Let's move on to the second. This one, I see I have a compound reacting with another compound. And what has happened over here, it looks like they just swapped partners. Two compounds react together. That is the rule for your double replacement. And we see that they did double replace. They just swapped partners. The third example, I have one reactant. There's only one rule that says you have one reactant. That's going to be our decomposition. And we see that that's indeed what it does. The PbSO4 splits up into Pb and SO4 separately. It is decomposed from one thing into two. Now things are getting a little trickier in the next 3 questions, as I have not provided any of the products. We're going to have to figure out exactly what's happening just by looking at the reactants. So example 4 here has iron and sulfur reacting together. Well, iron is an element and sulfur is an element. If you take a look at your rules, an element plus an element, just two elements, what's going to happen there is a synthesis. A synthesis is what happens when you have just two elements reacting together. Let's take a look at the fifth example, Hbr and KOH. Now you might think, oh, the HBr is a compound and KOH is a compound. Compound, compound, double replacement. And you would be partly right. But we should know better by now. We've talked about acids and bases a bunch. I notice, hey, this is H. This is an acid. This is OH. This is a base. Acids and bases reacting is called a neutralization. It is a more specific form, and we should be able to identify those. And now it's time for our very last example. Cu, copper, and Ag2SO3. Well, if I take a look, copper is just an element, and silver nitride is a compound. An element and a compound. The rule that we had for that was single replacement. So we've now been able to connect these rules with these examples, and hopefully you understand how I've been looking at my reactants. For example, taking a look at example 3 here, PbSO4 is one compound, and that's the only thing. So I took a look at my rules. Decomposition, there's only one reactant we can see here. That's how I use my table to help me identify these various products. If you have any problems, please be sure to send me a message or an email and I'll do my best to help you out. Good luck, everyone. We're going to have a quiz on this that is going to be due on Friday. Check the assignments folder. All right, have a good day.